Hi friends, in this video we are going to discuss about remaining all windings. What are the remaining windings? Integral slot winding, fractional slot winding, single layer winding, double layer winding, and balanced winding, unbalanced winding. Let's see about these three types. First of all, integral slot winding nothing but if the phase belt is equals to integer, then the winding is called integral slot winding. If the phase belt is equals to fraction, then the winding is called fractional slot winding. Integral slot winding and fractional slot winding. Up to now we saw the integral slot windings only. Now let's go for fractional slot winding. Before that, generally why we are using fractional slot winding? Because in integral slot winding, EMF not sinusoidal. But in fractional slot winding, EMF sinusoidal. Sir, why the EMF is not sinusoidal in integral slot winding? Because of slot and tooth harmonics. Because of slot and tooth harmonics, the EMF is not sinusoidal. That's why we are going for fractional slot winding. EMF is sinusoidal because slot and tooth harmonics eliminated. These harmonics are eliminated in fractional slot winding. This is simply about integral and fractional slot winding. Alright, let's see the example for integral slot winding. A 3-phase, 6-pole, 36 slots alternator. For example, slots per pole. Find the slots per pole. Slots per pole is the 6. And phase belt, nothing but slots per pole per phase. Nothing but, what is slots per pole here? 6. And phases is 3, nothing but 2. Here 2 is a integer. Hence this is a integral slot winding. For this distribution factor is same. Sin m gamma by 2 divided by m into sin gamma by 2. If it is uniformly distributed, you know the answer. This is very clear. This is normal thing. Now the special thing is this one, fractional slot winding. Sir, how we can get the fraction here? When we can get the fraction of m? Let's see. I will give you one example. Very important. Listen carefully. One example. A 3-phase, 10-pole, 42 slots alternator. 3-phase, 10-pole, 42 slots alternator. Tell me how many number of poles? 10. How many number of slots? 42. How many number of phases? 3. So, m is equals to slots per pole. First of all, tell me slots per pole. 42 of 10. 4.2. Then what is m? m is equals to slots per pole per phase. What is slots per pole? 42 of 10 by phases. Here the value, listen carefully how I am going to solve this problem. Listen carefully, you have to do the same, otherwise you can get the wrong answer. So 3 ones and 4s are. So m is equals to 14 of 10. Here the phase belt m is equals to 14 of 10. 14 of 10. This is a fraction. This is a fraction, that's why it is called fractional slot winding. This fraction is written as 2 times of 7 upon 2 times of 5. This is equals to k times of sk upon k times of pk. K times of sk upon k times of pk. Here k is the repeated sections, repeated parts or repeated terms or repeated sections, repeated sections. Sk is the number of slots for each section. Pk is the number of poles for each section, number of slots for each section, and number of poles for each section. Here, how many repeated sections are there? 2 repeated sections. Nothing but here 2 repeated sections. Nothing but how many poles for each repeated section? How many poles for each repeated section? 5 poles for each repeated section. 2 sections are there, 2 repeated sections. So 5 poles each. Pk, what is Pk? 5. The repeated poles are 5 and 5. And Sk, number of slots for each repeated section. Each pole, slots per pole. Actually, how many slots are there? 42. This 42 divided to 2 parts. Yes or no? So 21 each, 21. Like that. Here repeated is 7. 7 of each, 7 of each. Like that. Number of slots for each section and number of poles for each section. Slots per pole, like we have to calculate here. So this is very important. And for this fractional slot winding, distribution factor is very different. Distribution factor for fractional slot winding, distribution factor for fractional slot winding is equals to distribution factor for fractional slot winding is equals to sine m gamma by 2 upon sk into sine m gamma by 2 sk. Sine m gamma by 2 sk. Sine m gamma by 2 upon sk into sine m gamma by 2 sk. Sk is the sections, slots per pole, each section. This is the fractional slot winding. Like this, you have to calculate the distribution factor. This is already asked in GATE 2008, I think. 2 times they asked in GATE. Very important formula. You should follow this. You have to find out sk and you know the m, and gamma. Simply m gamma. We know the m gamma value. M gamma is equals to 180 by number of phases. 180 by number of phases. M gamma value we know. So we should know the sk. For that you have to do this. And then after you can get the answer for that. This is simply the fractional slot winding. Actually, this fractional slot winding concept in synchronous machine, the same concept in induction machine is called, very good, skewing. It is called skewing the slots. The rotor slots are skewed, right? The same concept. Here also and there also, slot and tooth harmonics eliminated. This is the concept of integral slot winding and fractional slot winding. Very important concept and very important formula. Let's go for next one. Single layer winding and double layer winding. Let's see what is the single layer winding and what is the double layer winding. What is single layer winding and what is double layer winding? Single layer winding and double layer winding. In generally, single layer winding nothing but one coil side placed under one slot, If one coil side placed under one slot, that is single layer winding. If two coil sides, if two coil sides placed under one slot, if two coil sides placed under one slot, that is called double layer winding. Single layer winding and double layer winding. Nothing but here number of slots is equals to number of coil sides. But here number of slots is equals to number of coils. Yes or no? Yes or no? For example, two coil sides. Two coil sides nothing but every coil having two sides. Two coil sides nothing but one coil. Here in one slot we are placing two coil sides, nothing but number of slots is equals to number of coils, number of slots is equals to number of coil sides. Number of coil sides. This is very important, and in generally double layer winding is more preferable. Double layer winding is more preferable comparatively. This is about single layer winding and double layer winding. And next and last type of winding, balanced winding and unbalanced winding. What is that? Balanced winding and unbalanced winding. For that we should know the phase group. What is that? Phase group. Phase group nothing but number of poles into number of phases. If the number of poles into number of phases multiply, then it is called phase group. If the number of coils in a phase group is a whole number of coils, is that right? Then thus that number of coils in a phase group is a whole number, then the winding is called balanced winding. When it is called balanced winding, it should be a whole number. For example, if number of coils in a phase group not a whole number, then it is called unbalanced winding. It is called unbalanced when this is not a whole number. This is simply about the remaining windings, fractional slot winding and single layer, double layer winding and balanced and unbalanced winding. These are the concept of windings. Clear? Thank you.